Welcome to the spoken tutorial on storage class specifiers. In this tutorial, we will learn about storage class specifiers, auto keyword, static keyword, extern keyword, register keyword with the help of an example. For this tutorial, I am using Ubuntu operating system version 11.10, GCC compiler version 4.6.1 on Ubuntu. To follow this tutorial, you should be familiar with C tutorials. If not, for relevant tutorials, please visit our website, which is as shown. I will start with an introduction to storage class specifiers. Specifiers tells the compiler where to store a variable, how to store the variable, what is the initial value of the variable, lifetime of the variable. The syntax is storage specifier, data type, variable name. Types of storage class specifiers are auto, static, extern, register. Let us start with auto keyword. Auto keyword declares an automatic variable. It has a local scope. Keywords are not initialized automatically. You should explicitly initialize keywords while declaring. Storage space of keywords is CPU memory. Let us see an example. I have a code file. Let us go through it. Note that our file name is auto.c. We have declared a function as increment. This is the main function. In the main function, increment function is called 4 times. Then we have the return 0 statement. Let us see the function definition. Here we have declared variable I as auto_int. It has a local scope. Then we display value of I using printf. Value of I is incremented here. Let us open the terminal by pressing Ctrl, Alt and T keys simultaneously on your keyboard. Type gcc space auto.c space -o space auto. Press enter. Type ./auto. The output is 0. Now come back to our program. Let us initialize the auto variable I above the main function. I will cut this declaration and initialization from here and paste it over here. Click on save. Let us execute on the terminal. Press the up arrow key twice. Press enter. We get an error. File scope declaration of I specifies auto. This is because an auto variable is local to the function. We cannot initialize it globally. Let us fix the error. Come back to our program. Delete this. Paste it over here. Click on save and execute on the terminal. Press the up arrow key. Recall the previous command. Press enter. Type ./auto. Press enter. Yes, it is working. The output is 0. This is because we have initialized the value of I as 0. Now let us see static variable. Although we have studied about static variable in the previous tutorials, I will explain it briefly. Static variables are initialized to 0. They are not destroyed even after program control exits from the block. Value of the variable persists between different function calls. Storage space is CPU memory. Let us see an example. I will edit the same code file. Come back to our program. Press Ctrl, Shift and S keys simultaneously. Now I will just change the file name as static. Click on save. Now I will change the initialization of the variable I to static int I equals to 0. Click on save. Let us see what happens. Execute the file on the terminal. Type gcc space static.c space -o space stat. Press enter. Type /stat. Press enter. The output is displayed as 0, 1, 2, 3. This is because static variables are global variables. The scope of static variable is local to the function they are defined in. They do not lose their value between function calls. Now let us learn about extern keyword. Scope of extern variable is throughout the main program. Definition for extern variable might be anywhere in the C program. Extern variables are initialized to 0 by default. They can be accessed by all functions in the program. These are stored in CPU memory. Let us see an example. I have a code file. Let us go through it. Note that our file name is extern.c. I have initialized a variable as integer variable x to 10. This is the main function. In the main function, I have declared an extern integer variable y. Using the printf statement, we will display the values of x and y. This is the return statement. We will initialize y to 50 after the main function close. Now switch to the terminal and let us see what will be the output. Type gcc space extern.c space -o space ext. Press enter. Type /ext. Press enter. The output is displayed as the value of x is 10, the value of y is 50. As we studied, the value of the extern keyword is throughout the main program. We can define it anywhere in the program. Both the statements are justified. Now let us move on to register keyword. Register variable will be accessed faster than normal variables. They are stored in register memory rather than main memory. Limited number of variables can be used since register size is very low. 16 bits, 32 bits or 64 bits. Let us see an example now. I have a code file. Let us go through it. Note that the file name is register.c. Here we have declared register integer variable. This variable will be directly stored in the register memory. This is the for loop that displays the value of I from 1 to 5. This will display the value of I. Let us execute the program and see. On the terminal, type gcc space register.c space -o space register. Press enter. Type /register. Press enter. You can see the output is displayed as value stored in register memory 1, 2, 3, 4, 5. This brings us to the end of this tutorial. Let us summarize. In this tutorial, we learned storage class specifiers, auto keyword, static keyword, extern keyword, register keyword. As an assignment, write a program to print the sum of first 5 numbers. Declare both the keywords auto and static in the program. Watch the video available at the link shown below. It summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. The Spoken Tutorial project team conducts workshops using spoken tutorials, gives certificates to those who pass an online test. For more details, please write to contact@spoken-tutorial.org. Spoken Tutorial project is a part of the Talk to a Teacher project. It is supported by the National Mission on Education through ICT, MHRD, Government of India. More information on this mission is available at the link shown below. This is Ashwini Patil from IIT Bombay signing off. Thank you for joining.